Welcome back to Social Data Analysis. In our previous lesson, we dealt with bivariate regression analysis, and our independent and our dependent variables were both continuous variables. But what do you do when your independent variable is a categorical variable? And what are categorical variables in the first place? So that is what we're going to do in this lesson, categorical variables and how to conduct regression analysis using categorical variables. There's so much to learn. So stay with me. If you haven't yet subscribed to Social Data Analysis, please do that because we bring so much more about data analysis and research methods in general just for you. See you in the lesson. Welcome back. So let's roll back a little bit and talk about types of variables in general. First of all, we should know that there are four main types of variables that we use in quantitative research. The first type, we are dealing with continuous variables, and then we have discrete variables, and we have nominal variables and ordinal variables, which form part of categorical variables. With continuous variables, we are talking about any variable or any column in our data set that can take on any infinite values or infinite numeric values. For example, gross domestic product per capita. The GDP of countries can be $1,065.2 per capita. We can talk about other variables such as weight, temperature, income, which are all continuous variables, right? Because they can assume any value and they can assume infinite values. So last week, these were the types of variables that we dealt with. There are two types of categorical variables. There are ordinal categorical variables and there are nominal categorical variables. With nominal categorical variables, we are talking about categories within your data set that only exist in name only. There are no specific ordering to them. So a typical example of a nominal variable is race. There are whites, there are blacks, there are Hispanics or Latinos, there are Asians. These categories exist in name only, and you cannot order them and say one race is better than the other race. You could also take another variable like sex, male and female. You could say, well, they exist in name only. You cannot say that females are better than males and vice versa. But we also have another form of categorical variables or category variables that are categories, but they are ordinal variables. And ordinal variables are categorical variables or variables that are categories that we can order, categories that exist in some hierarchical form. So an example of that is the level of education variable. A level of education variable can have values like basic education, and then next level is junior high school, then senior high school, bachelor's degree or master's degree, then a PhD. So you could see a categorical variable called level of education can have these hierarchies. Other variables like customer satisfaction, very satisfied, satisfied, not satisfied, can also be grouped in hierarchy. They are ordinal, they can be ordered. In a previous lesson, we used the World Development Indicators data sets, and then we used the GDP per capita as an independent variable. Remember, GDP per capita is a continuous variable, so it assumes infinite numbers. Today, in our lesson, we are going to do a new analysis. We're going to use a new GDP variable that only groups countries into three categories. It groups countries into low, medium, and high income countries. So this is quite different from a continuous variable. This, as you have seen, is an ordinal categorical variable. It is quite obvious that low income countries are on the bottom. You have middle income countries and you have high income countries. So countries are ordered in this particular category, and then that is going to be our independent variable. Our dependent variable for today's analysis is life expectancy. So what we want to analyze today, or Our hypothesis going into today's lesson is that people in countries with higher GDP live longer than live longer on average than people in countries with low and medium GDP. So count people who live in countries with a higher GDP should on average live longer than people who live in countries with a low GDP. We are going to do this analysis using R programming and see what we find. All right, so a picture, they say, speaks 1,000 words. First of all, and as usual, let's go to our R Studio and use ggplot2 to visualize our GDP variable and see what are the trends, what can we observe. Then after that, we're going to use dplyr, which is also part of our tidyverse package, to do some calculations and investigate our data further. We want to calculate the average life expectancy for various GDP levels before we even get to our regression analysis. So let's go to our R Studio and let's code this together. I'm going to put the code for this lesson in my GitHub. The link is going to be in the description. So let's do this together and learn something new. I am in my R Studio. First of all, let's start by giving a title to this analysis that we have here. Let's call it Bivariate Regression with Categorical Variables. Oh. And let's create a header with that. The first thing I would want to do is to load my ggplot2 and dplyr packages into R, as we do all the time. If you don't have ggplot2 and dplyr package, you have to install them as we have discussed in our previous videos. Okay, so ggplot2 and dplyr is loaded. We are in R Studio now. So the first thing I would want to do, as usual, is to load the packages that I would want to use for my analysis. In this analysis, we're going to do ggplot2 and dplyr. So I'll go ahead and load them into R. As usual, I would always want to have a look at my data set, right? Have a look at my data set, just a snapshot of the world development indicators, and see how are the variables labeled, what are the values in my variables and things like that. So I would always want to have a snapshot of my data set. Okay, so this is what my data set is about, and we usually do most of these things. So let's go ahead and start with using ggplot2. We want to visualize our GDP versus life expectancy relationship. And remember our hypothesis. Our hypothesis is that as countries increase in categories for GDP, for example, from low to medium income countries or from medium to high income countries, people in that country would live longer on average. Okay, so I have this code here, which I'm going to break down for you. So I call my ggplot, which we know is the function that is actually going to give us the plot that we want, the visualization we want. The first argument is our world data set, and we want to include some aesthetics. The first aesthetics that we want to include is our dependent variable. Now, contrary to previous functions, this time we just want to have the dependent variable, which is life expectancy, standalone, right? And we add a histogram. We want to do a histogram for this graph instead of a scatter plot like we did the last time. Remember in our previous lesson, our scatter plot didn't really make sense for categories. So we are not going to do a scatter plot, we're going to do a histogram. So this is how we go about it. We add a histogram function called geom histogram, and then we specify the number of bins or the number of bars that we want for a histogram, and we wrap on this histogram our GDP categories, that is low, medium, or high income countries. Now let me run this code and we see what we get. Right. So as you can see, there are four categories. One category is all about missing values, but there's also another category about low income countries, middle income countries, and high income countries. And you realize that it looks like people who live in high income countries kind of live longer than people who live in medium income countries and low income countries, right? So this is worth some investigation. Let's really delve deeper into this and find out what is really going on here. And the next thing I want to do is, I am not happy with the fourth graph, which is the graph for missing values. So I want to take out the missing values in my data so that the next time I do this graph, I have just 3 columns instead of 4 columns. So again, we've done something like this before in our previous lesson when we dealt with data frames. I want to remove my missing values, so I called my data set and I put in an exclamation mark s.na, and then I call the column which I want to remove the missing values for. Now I bring a comma and I leave some blank space because I'm only interested in these columns and not any other rows. Okay, so I go ahead, and as you can see on your top right hand corner, the number of observations has reduced from 167 to 156. It means that some observations have left our data set. We successfully removed missing values in this data set. Let's go ahead to do this graph again and see what we got. Okay, so this time I want to label my graph. I want to label my x-axis. I want to label my y-axis as well. So I include a new line of code which is called labs, which is a function for labels. The x-axis is going to be life expectancy, y-axis frequency, and title is going to be life expectancy by GDP level. If I run this code here, what I get is my missing values is out, and I have just three different graphs. And we can still see that, oh, it looks like people who live in middle income countries are somehow also doing well, and people like it looks like it's quite similar between middle income countries, high income countries. So we really have to delve deeper into this before we draw any conclusions. But it's obvious that people who live in low income countries live less on average. But let's not conclude yet. Let's go into this analysis and see what we find. This is where we call in our dplyr package. We want to compute the average life expectancy for each GDP level, right? We've seen a picture of it, but we really want to be sure of what is going on here. Let's look at some numbers also before we get into our regression analysis. So this is a code that uses dplyr to compute averages. Wow, dplyr is so amazing. I love it. And let's go through this code and see what it's doing. I created an object called life average, and I assigned to this object my new data set that I got after taking out the missing values. I connected it using a pipe by a group by function. Now, what a group by function does is that if I input as an argument my independent categorical variable, whatever calculation that I'm doing, I'm going to group it by the various categories. So in this case, I'm going to group it by low, medium, and high income countries separately. And I connect this also with a function called summarize. What summarize is actually doing is that summarize is taking into account my average function. So my average function is called mean, which is going to give me the mean life expectancy of all the three different categories. But the summarize function is going to put everything together into a new column that it will create called average life EX. This is simply creating a new column and assigning this new column with the mean averages of each of the categories in our column. This is so amazing. And the last thing I have here is if there is any missing values, remove it from my analysis. So let me call life average and see what we have in this object as the averages of the various categories we have in our GDP variable. Oh, yeah, I have to run this code first. Okay, and life average. So I'll go ahead and run my code, and let's go ahead and look at what is in our life average column now. Okay, so in this new column that we're going to have called average life EX, which is embedded in an object called life average, we can see that even before we do our regression analysis, there's some evidence that people who live in high income countries tend to live longer than others in middle and low income countries, right? And sort of it goes on like that. This is some overwhelming evidence, but before we end, let us do our regression analysis and get some extra evidence to support our hypothesis, right? That indeed people who live in high income countries live longer on average than their other counterparts. So let's go straight to regression analysis. This code is similar to what we dealt with in our previous lesson. We use the same LM function for conducting a regression analysis. We have a dependent variable coming first, and we have our tilde with our independent variable, then our data set. We are using the world clean data set, which is what I have created after taking out missing values from the world data set. Now let's run this regression analysis and see what we got. All right. In our regression analysis, this is what we have. Let's go through the output. We have an intercept which is 60.41, and it seems that when countries move to a medium income country, there's a 10.3 increase in average life expectancy, and when countries move to higher income countries, there's a 16.3% increase in average life expectancy. But let's look at the intercept carefully. Remember in our previous lesson, we said that the intercept is the value of our dependent variable, or the value of y when x doesn't exist or when x is 0. Are we do we understand, do we really understand that the intercept in this case means that when countries are low income countries? So this is how categorical variables are different from continuous variables. With continuous variables, you can easily say, well, our independent variable doesn't exist, and the intercept is the value of our dependent variable when our independent variable doesn't exist. But we have three categories now. We have low, middle, high income countries. and low income countries do exist. They are in the world right now. So what do we mean by the intercept right now when we are dealing with categorical variables? Are they the values of our dependent variable when countries are in the barest minimum category in our data set? Are we trying to say that the intercept is the value of y when countries are in the lowest category of that particular variable? Okay, what if we could correct our code just a little bit to offer clarity? Let's go back to RStudio just for a few seconds and correct this regression code to be much more clear about what our intercept actually means. So this time, instead of running my regression model with the code on line 32, I'm going to modify the code on line 32 just a bit to make my output clearer. Now, observe that I have included +0 to my code for the regression model. Why did I do this? Remember we said an intercept is the value of y when x is 0. If that is the case, what if we could say, all right, now we already know that x is no more 0 and we are moving to the next category in our data set. What will be the value of y? In other words, for categorical variables, we cannot really say that a particular country doesn't exist. In other words, for categorical variables, we cannot really say a particular category does not exist, right? Because in the real world they really do exist. So adding +0 takes off that assumption of absence of our independent variable, and then it makes our regression model start from a scenario where every category in our column or every category in our independent variable really exists in the real world. Let's run this code and see the difference in output. Okay, great. By correcting our code and adding +0 to our independent variable or our categorical variable, we take out that assumption of the intercept, and that our output is much more clearer. So we have our intercept taken away, and it is now replaced by the actual coefficient of countries with low GDP. So this is how you would interpret this regression model. Remember that in a categorical ordinal variable, low is down, medium is better than low, of course, and high is better than both. So 60.41 means that when countries 60.41 means that when a country is a low income GDP country, on average we expect people to live 60.41 years in that country. As countries improve upon their GDP and become middle income GDP countries, you can see that people in that country live up to 70.71 years old on average than people in low income countries. When countries improve to become high income earning countries, people in that country move people in that country live up to 77.04 years on average than their counterparts in low and middle income countries. This is how we deal with categorical variables. By adding +0 to my categorical variables, I have changed the whole dynamics with dealing with coefficients to dealing with the actual value or the actual average value of how old people live. The other code is also correct. So if I go back to my previous code, you could interpret it as when countries are low income countries, people live up to 60.1 years on average. But when that country improves to become a medium income earning country, you can have a 10.3 years increase in how old people live. When people improve and when the countries improve and become high GDP countries, you can have 16.63 years added to how people live on average. So this is the difference. What makes the difference is adding plus zero to your code to change how exactly your regression output becomes when you are dealing with categorical variables. I hope this is clear. Dealing with categorical variables is that simple. This is not hard. The only thing you have to do is you need to understand that with categories, you might not have the intercept behaving the same way as continual variables. To offer yourself much more clarity, you might choose to add plus zero to your independent variable and interpret the regression output in a different way. But regardless of how you do it, now you know how to interpret regression output when dealing with categorical variables. I hope this was clear. We were able to confirm our hypothesis, or we were able to accept our hypothesis that people who live in high income GDP countries live longer on average than their counterparts in middle and low income countries. This is great analysis, and we're going to take it a step further by dealing with a new topic in regression models. If you haven't subscribed to this channel, do that, and let's learn regression analysis in R together. See you in the next lesson. Bye.